Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solutions for systems of inequalities. This is standard A.3H in the great state of Texas, and we are using item number 47 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got this graph showing these two lines, y equals 2x plus 5 and then x plus y equals 1. What they want to do is they want to turn both of these into inequalities. And so we need to find which order pairs in the solution set. Well, let's open up our graph draw feature. We need to do a little bit of shading here. I'm going to increase the transparency so I don't see the grids behind that. So let's take a look at this first one right here. This is already in our slope-intercept form. Y is greater than or equal to 2x plus 5. So what do we know? This is our y-intercept. That's why this form is so helpful. So y-intercept is 5. See that right there. And then my slope is going to be my 2, right? So it's going to be up 2 over 1, right? So it's this line right here. Let's shade that right there. All right, so it's that line that we're talking about. Now, what do we know about the solution set? Well, it's the y is greater than or equal to. So when we are dealing with greater than or equal to, greater means more, you actually need to shade above the line. So what I'm going to do is I'm going to just draw some little bit of shading right there above that line. Now let's look at this other one here. X plus y equals 1 is what's shaded, so it's x plus y is less than or equal to 1. Now both of these have a greater than or equal to or less than or equal to, so I can keep the solid lines. If you ever have just a greater than or less than without the equal to, you need a dotted line, which means you cannot include a number that's on that line. But since we've got the greater than or equal to or the less than or equal to, we can actually use this solid line. We're good. So we need to just isolate this y. So let's get that x over on the other side. So it's y is less than or equal to negative x plus 1. So here's my y-intercept, right? It's that plus 1, that positive 1. And then I've got a negative x. So that's my m. So there's no coefficient there. But when you don't see one, you can always imply a 1, so it's just negative 1, so it's going to go down 1 over 1. And so that's what we have. Now we have a less than or equal to. So if our greater than or equal to make a shade above, our less than or equal to are going to make a shade below, because less means below. So I'm going to take this line right here, and I'm going to shade below, and look at the overlap. Right, so when I find a coordinate pair that's within this grid right here, that's what I'm looking for right here. That's the overlap. All right, so let's switch to green and let's start graphing some of these points. So negative 5, 0. Oh, that looks like that might be it right there. Negative 5, 0. That's A. That looks pretty good. 0, 7. So 0, oh, that's only in one of the two pairs, so that's not going to work. Let's see, 5, 0. That's nowhere. It doesn't sit in any of the solution pairs. Now I do need to shift this down a little bit, which is going to make my drawing look a little bit weird. 0, negative 7. All right, let me see if I can get this line back up. D is 0, negative 7, correct? Yeah, so let's graph that real quick. 0, negative 7, it exists in one of our solution sets, but not both. It's down there. So that makes it very clear that our answer here is going to be A.